Hello, my name is Igor, and in this episode I'm testing can I drill into 3D printed plastic. Why would I like to do that? Well, for example, if I forget to design a hole in 3D printing, I don't want to reprint everything again. Or maybe I just want to raise the diameter of the hole because I want to put some shaft or ball bearing inside. Or maybe I have a vertical hole, and if I don't want to use the supports with bigger holes, I need some overhang and bridging, and maybe the solution is to print it a little bit smaller and then raise the diameter by drilling. I don't have too much experience so far with drilling into this 3D printed plastic, so I have to find answers to several questions like what type of the twist drill bit to use, or can we drill into 20% infill, or maybe it has to be 100% solid plastic. How accurate is the drilling into plastic? Can we raise the diameter? Will it melt during the printing? Because probably the PLA will be harder to drill compared to PETG because it has a lower heat deflection temperature. So most of the tests will be with PLA, but I will do some testing with PETG, and I want to find out, can we use a step drill bit or maybe a countersink. This will be a longer video. I have to do a lot of experiments here, but here you can see the timestamp, so you can jump to any part of the video, or you can just jump to the conclusions and see what I learned from these testings. Let's see those test probes first. These are my test probes in Fusion 360. Only this one here will be with 100% infill. Everything else will be with only 20% infill. This is 4mm diameter just for reference, and I will try to create a hole here with the 4mm. This one will be with 2mm, and then I will raise the hole with heated nail. And same will be in vertical position, because I'm curious, is there any difference in drilling in a layer direction or perpendicular to the layers. Now these two holes, this one is 10mm, but this one is 9.5mm, so I want to check that can I use a 10mm twist drill to raise this diameter to the 10mm, because here we have some perimeters. Now printing in vertical position. For printing holes in vertical position, if the hole is big, then it cannot be printed without any supports or overhang. So usually the method which I use is this. So I have here the bridging, and this is some overhang which I can print without problem. And as you can see here, the shaft or bearing can go inside this hole without modification. But I'm curious if I could print this smaller, and then using a drill bit to raise the size of the hole. And same I will do with these bigger holes. And as you can see here, I added on the bottom this overhang too, because if I start to drill, this will be drilled with a step drill, and it will stay in the center because the load is on two opposite symmetrical sides. And this hole is 9.5mm, and also I want to check, can I use the step drill to raise the diameter of this hole. And I have here just 20% infill object printed horizontally and vertically, and I will just start drilling and to see what will I get. This is now previewing a Prusa slicer, preparing for 3D printing. And as I mentioned, only this one object will be printed in 100% infill, so I use here a box modificator. Everything else will be printed in 20% infill with only 2 perimeters and only 3 top and bottom layers. This is the print preview of the printing. As you can see, I will use here 6 meters of filaments. Printing will be 2 hours and 10 minutes approximately. Holes will be created on this old drill press. I measured from this slow motion footage, the RPM was 700 rotations per minute, and this was the lowest I could set up on this machine. These are most common twisted drill bits, and let's see which one to use for our 3D printed plastic. First one is the twist drill bit for stone or brick, and I'm sure we cannot use it with the plastic, so just forget about it. The next one is for wood. So here you can see this part in the middle. It is to give a direction for the drill bit, and the rest will do the drilling. But it works when you are drilling into solid material like wood or 100% infill of the plastic. So I retested, but only once with the 100% printed object. And this one is for metal. So in most cases I'm using this twist drill bit. And I notice it has to be sharp because it will give a nicer hole, especially on the exit of the back side of the hole. I started with drill bit for wood. This one is 4 mm in diameter, and I'm starting drilling into 100% infill PLA in layer direction. And as you can see, I'm using a wood on the other side, and I'm holding with my hand the piece in one place. It's a little bit hard to hold it in one place because I don't have that big pressure like drilling with the metal, and don't have that friction on the other side. Here you can see the matting of the plastic. So this is the biggest enemy in drilling plastic. You will see the other side of the hole is quite clean, but here the matted plastic deformed the hole, and also it's very hard sometimes to remove it from the drill bit. Same results I got drilling perpendicular to layer. So again, still I'm using a drill bit for wood. It was very hard to hold the piece in one place because I don't have that pressure which will result in friction on the other side. And here again you can see the melted plastic again deformed the hole. Okay, now here I'm using a drill bit for metal, and I'm using a lubricant which usually I would use with drilling with the metal, but here it doesn't have at all, so it was just a test. And now you can see I don't have anything, I don't have anything on the other side of the hole, so the object is still holded in the vise, machine vise. And here the plastic again melted and deformed the hole, and also stayed around the drill bit, which is a little bit hard to remove. Now you can see the back side of the holes is very clean. So, and now I didn't use the wood on the other side. And same results I got here drilling in layer direction. So this is the same piece, 100% infill, drill bit for metal. And here I try to simulate drilling into metal, so you can see I try to take out from the hole, which usually I would do drilling metal, to remove the chips, but it doesn't have. So here what would have, probably lowering the RPM, but this was the lowest on this drill press. And now in the rest of the video I'm using drill bit for metal, and this is 20% infill PLA. I started perpendicular to layers, and very nice and clean hole I got. So I was surprised, and of course I didn't use wood on the other side. And same result I got in the layer direction. The only problem, you can see a little wobbling, that I don't have the big pressure like with drilling with the metal, and I don't have enough friction on the other side to hold the vise in place. In my next experiment I tried to drill, this is 2 mm in diameter, metal drill bit, and you will see very clean hole, because now the tangential speed is much lower because it depends from the diameter and the rotation per second. And here, since the diameter is much smaller, you can see very clean hole. The reason I tried to use a heated nail to create the hole, but I got the same result, so even worse. It's better if you drill it with the correct size. And now in this experiment I'm using a 10mm diameter drill bit, and to see, can I, for example, raise the hole. From some reason it's smaller, and this one is 9.5mm hole. And you will see it works, but it resulted uglier surface, so it is better to use the correct size in 3D printing. This one is printed in vertical position with those overhangs. And let's see, can we raise the sides to get correct shape. And I tested with this 10mm diameter drill bit, and it works. So the method works, but it's much better. So this one is printed with those bridging and overhang, and that surface is much better. And now in this experiment I just started with the drilling into 20% infill PLA. This hole is 3mm in diameter, then I raise it with a 10mm drill bit. And you will see, very interesting, the plastic melts, but because it is only 20% infill, it creates some walls inside, so we can have some kind of perimeters, and it's very strong, so I thought it will be much weaker. And then this is other location. I tried to raise it with the step drill, and it also works. So it looks like inside it melts the plastic and creates the walls, because theoretically in 20% infill we should see holes inside of this object. Now the only problem you can see here on the other side with this step drill bit, but if I turn it and use on the other side, it will correct the shape of the hole. So you can see this piece was printed in horizontal direction. And now this one is vertically printed, so now I'm drilling in the layer direction. But same results I will get here. You will see I started with 3mm, then 10mm. And yes, you can see here the only problem is that it is very hard to hold it in place, because I don't have that pressure to resolve that friction. It is much better if you could fix the vase during the drilling. And now one more test. I will again try to use the step drill bit. Of course I'm using in speed 1, where I have a higher torque and lower RPM. Yes, the camera focused here on the rocks. You can see there are no holes on the side of the hole. Very interesting that basically that melted plastic now create that wall around the hole. Okay, let's fix this hole on the other side. Okay, now in this experiment, this is now a new piece. This diameter is 9.5mm, and I want to see, can I use the strap drill to get 20mm in diameter. This is also 20% infill, but of course now we have several perimeters around the hole, so in theoretically we shouldn't see the holes in the wall of the cylinder, whole cylinder. And because here we have those perimeters in this hole, even on the other side the hole is quite nice. So this method may be used, but of course again it's much better if we can 3D print the correct size. But I am very happy with this shape. And now this piece was printed in vertical position, because so we have here those overhangs. So let's see, can we use this step drill to get correct cylindrical shape? Because with this big hole we cannot 3D print this if it is in vertical position. And it looks like it works. So just a little bit correction on the other side. You can see a small hole there in the cylinder, because there we drilled the perimeters, but it's very nice. So here I had only 2 perimeters in 3D printing. I was curious, can I drill a TPU? So I found this old corner guard I printed half years ago. And I created a 4mm hole inside. It's drillable, but you can see the hole is not so nice, especially on the exit of the drill bit. But of course it's drillable, and that material can be removed, and it's also melted. Now I found this old PETG material, and it has higher heat deflection temperature, so it doesn't melt so easy. And this hole was extremely nice on both sides. This is the top of the hole and this is bottom of the hole. But maybe this is disadvantage because inside the material wasn't melted and it doesn't create that wall around the hole. And this is countersink tool, just to see what we will get with this tool. And it works, but as you can see, we can see that infill gaps, and same results I got with the PLA. Unfortunately, this surface is very ugly, it's not usable. So what I learned from these testings, first of all, I will probably use a twist drill bit for metal. Lower RPM are much better. And what was very surprising, that drilling into 20% infill was better, nicer, easier compared to the 100% infill, because that melted plastic didn't go around the drill bit, but it created very nice wall in the cylinder of the hole. Raising the hole a little bit to get correct size will work, but the surface is not so nice. It is much better if you can print with correct size. Of course, if something will go inside, you cannot see those walls inside the hole, so it doesn't matter too much. Vertical holes, yes, it also can be used, that method that you can print a little bit smaller and then correct the size and diameter with the drilling. But probably I will stay with that method where I can print that bridging and that shaft or bearing will go inside and I don't have to drill it at all. Countersink drilling will work, but then the holes will be very visible if it was very lower infill. It was surprising that step drill works very fine, and that melted plastic created very nice wall around the hole. But on the other side, on the exit, we have to fix it because plastic go outside. So if it's possible, you have to turn the object and fix it from the other side. Very interesting with the twist drill bits, if it is sharp, then the exit of the bit is very sharp, so you don't have to use wood or something drillable on the other side as a support. Since the plastic is soft and you cannot press it so hardly from the top, this means the friction on the other side is not too big. It can move on the desk, so it is best if you can fix the vase and to hold the object in one place. In that case, the drilling will be much better. Well, that would be it from my side. I'm sure I will learn a few more things, but I hope I will get some useful comments. So if you have some other experience, feel free to write me in the comment and share it with the others. Thank you for watching and happy drilling. Bye.